Let's solve this system of DEs, and we're going to get complex eigenvalues here. So just like always, we solve the determinant of A minus lambda I equals 0. So that will be 3 minus lambda, 9, negative 4, negative 3 minus lambda equals 0. Multiply that out on your own and see you get lambda squared plus 27 equals 0. So lambda is plus or minus the square root of negative 27. So lambda is plus or minus 3i root 3. I'm going to take the top one, lambda 1 is plus 3i root 3, and use that one. Could have used the other one, but we'll use this one. Now we need to find our eigenvector. We're going to leave it complex for now. We'll use Euler's formula in a minute to realize everything and make everything real. So to find our eigenvector, we want A minus lambda I times k equal to the 0 vector. So that will be 3 minus 3i root 3, 9, negative 4, negative 3 minus 3i root 3. That's A minus lambda I times k1, k2 equals 0, 0. Now, just like always, we do not get two independent equations here. The top and the bottom are actually the same equations. I'm just going to write off the top. That will be, remember, it's row times column equals element. So all of this times this, that will be 3 minus 3i root 3 k1 plus 9 k2 equals 0. Okay. So we could move this guy over. 3 minus 3i root 3 k1 equals negative 9 k2. And for simplicity, remember, we could pick whatever we want for either of these. We pick this one and solve for that one. So I'm going to say k1 equals 3 because it makes the math work out easier. If we plug that in there and solve for k2, you should check these details on your own. We get k2 will be negative 1 plus root 3i. So my eigenvector is 3, negative 1 plus root 3i. Okay, now let's write out what we have. Okay, now we could have found the second eigenvector using the other eigenvalue, but you'll see we won't need it. So we're going to write out our solution from this eigenvector and say x1 of t is e to the 3 root 3i t times this eigenvector we just found. Now we're going to use Euler's formula. You may remember this, Euler's formula says e to the I theta can be rewritten as cosine of whatever is after the I plus I sine of whatever is after the I. We're going to use that to rewrite this in terms of sines and cosines. So here is what's playing the role of theta, and there's my I. So this will equal cosine of 3 root 3t plus I sine of that same argument, 3 root 3t, times this vector, 3, negative 1 plus root 3i. Okay, we're going to go ahead and multiply this together. We're going to remember, this is just a scalar. This is not a vector. So this is just going to multiply top and bottom. This is a scalar times a vector. So this will be 3 cosine of 3 root 3t plus 3i sine of 3 root 3t. And then we're going to take this into here. This is a scalar, multiplying that number, but we're going to have to FOIL there. So I'll get negative cosine of root 3i cosine a negative 1 times that I sine, so negative I sine 3 root 3t, and then finally these guys. That I and that I will multiply together and give us a negative 1, so we get a negative root 3 sine of 3 root 3t. Okay, now we're going to rearrange this and split this vector up into two vectors. All the stuff that's real over on the left, all the stuff that has i's over on the right. So on top, that part's real. On the bottom, that's real, and that's real. These two guys have i's. So I'm going to separate out all the real stuff and all the imaginary stuff. I need some space here. It's a long, complicated process for these. So I'm going to rewrite this as x1 of t equals, here was all the real stuff. Up on top we had the 3 cosine 3 root 3t. On the bottom I had negative cosine 3 root 3t minus a root 3 sine 3 root 3t. And then all the stuff that had an I in it, I'm going to bring that I out. Here's all the stuff on top that had an I, 3 sine of 3 root 3t. And then we had a negative sine 3 root 3t and a root 3 cosine of 3 root 3. Okay, we're going to call this guy U and this guy V. So what I've written here is x1 of t is U of t plus I V of t. These are vectors. Well, it turns out that U and V are, forget about the I, all the real stuff, make that a vector. All this stuff that had the I without the I, these are linearly independent vectors, and these work perfectly well for our general solution. So I can drop the I. I can say that my general solution then is x equals c1 u of t plus c2 v of t. So my general solution then will be x equals c1 3 cosine 3 root 3t. I'm just recopying all this. Negative cosine 3 root 3t minus root 3 sine of 3 root 3t plus c2, and then all of this stuff without the I. 3 sine 3 root 3t, negative sine 3 root 3t, plus root 3 cosine 3 root 3t. Okay, and then there's our general solution. So we find our eigenvalues, we get complex numbers, we use that in its normal form, use either one, the plus or the minus version, find our eigenvector. We strategically pick either K1 or K2 so that we get nice pretty numbers. And then we write out our solution, separate all the real part, all the imaginary part. Those become our vectors in our general solution.